Okay, so I really am beginning to like this app, and I've already done 2 videos, and I'm going to do another one, and that's a refresher on all things simplifying radicals. And I'm going to start by some very basic ones that everybody should already know. For instance, the square root of 9, and the square root of 16, and perhaps the square root of 25, and maybe the square root of 49. And when I think about that, and I try to remember what a square root is, and keep in mind there's a hundredth root and a cube root, and we're not restricted, but if you don't see a number over here, like that, then we assume that it's a square root. So you might see it like, square root 9 the way I have it, or you might see square root with a 2 there. But it's an implied square root if you don't see a number in front. Well, it's not in front. It's just, where the little v is in my radical. Okay, so when I simplify this, one of the things that I'm seeing a lot of students make a mistake is that if I ask them the question, what's the square root of 9, they say 3. But for some reason, they're writing square root of 3 on their papers, and that is completely crazy. So when we're doing this, and we try to, I know you memorize these things, but do you even know why it is that? And when you understand, when you're doing a tree, and you say that's 3 times 3, for every 2 numbers being multiplied together under the radical, it's equal to 1 on the outside. So when we say the square root of 9 is 3, it's because this operation, the square root, for every 2 of the number, which is these 2 3s, is equal to 1 on the outside. Just like 16 is 4 times 4, so the answer would be 4, because for every 2 of a number, it's equal to 1 on the outside. Notice the radical goes away. Just like that, the square root of 25, that's 5 times 5. For every 2 of a number under the radical, it's equal to 1 on the outside. And also with 49, that's 7 times 7. Every 2 of a number under the radical, it's equal to 1 on the outside. So the square root of 9 is 3, the square root of 16 is 4, square root of 25 is 5, and the square root of 49 is 7. So hopefully nobody is surprised by that. Okay, so I'm clearing that, and now I want to talk about what happens if my radical is not a number that is a perfect square. So, for instance, the square root of 9 is 3, but what about the square root of 27? Well, the square root of 27, you didn't memorize that in your tables because it isn't a perfect answer. So you start by doing a factor tree. So 27 is 3 times 9. Now, you look at those 2 numbers and you say, can I go any further with that? And yes, you can, because 9 is 3 times 3. And always bring down the one that you already have, because you don't want to lose any of those. So the square root of 27 is 3 times 3 times 3. Remember, I said for every 2 of a number under a radical, it's equal to 1 on the outside. So here is a group of 2 3s, so that goes on the outside. But I still have this other 3 all by itself, and he's sad. And he doesn't get to go outside. So he has to stay under the radical. So the answer to the question square root of 27, when we simplify it, the answer would be 3 square root 3. And if you're not sure, if you have, if you forgot during a test and you can't remember how to do it, you can always type in square root 27 in the calculator and hit enter, and then type in 3 square root 3 in the calculator and hit enter. And if the decimals are exactly the same, then you know you're doing it right. Okay, so I'm going to give you a few problems to do, and I'll wait just a minute, and then I'll start going over them. So when I put these problems up, if you'll pause it, and then you can work out the problems, and then I'm going to go through a solution. So give me just a second. Okay, so I wrote 3 problems for you to try on this board. And so if you'll pause the pause this video and get a piece of paper out and attempt to work these the way I just did the first example. Then you can come back to me in a minute and we'll double check and see if you did them correctly. So I'm going to just give you a second to pause it right now. Okay, so hopefully you went and did these problems, and now we're going to check our work. And so we start by figuring out, okay, what two numbers multiply together to get 75? And the two numbers that come to mind for me is 3 times 25. And then I look at these two numbers and say, can I take it down further? And the answer is yes, because 25 is 5 times 5. So I've got two 5s here, and then this 3 here. Remember, when we take the square root, we're looking for two of the same number under this radical. So I've got two 5s here. So the 5 goes on the outside. For every 2 that's under this radical, it's equal to 1 on the outside. But I have this 3 that doesn't have a partner. He can't come outside, and he has to stay inside. So you should have gotten 5 square root 3. Okay, next problem. So here I have 18. 18, when I think about what two numbers multiply together, you could say 2 times 9 or 3 times 6. I'm thinking 2 times 9. And the reason for that is as I go through this in my head, I divide by perfect squares. And 9 is a perfect square because 9 is 3 times 3. Just like on the previous problem, 25 is a perfect square because it's 5 times 5. So, I've been doing this for a long time, and I've had a lot of practice. And as you continue working on this, you'll start thinking about dividing by not just 2, but can I divide this by 4? Because 4 is a perfect square. All right, so on this one, it's 18 is also 2 times 3 times 3. 2 times 3 is 6, and 6 times 3 is 18. So again, I'm looking for two of the same number, and I have two 3s. So that means the 3 goes on the outside, and I'm left with a 2 on the inside. So the answer for this one is 3 square root 2. Alright, so I've got one other one here to do, and again, I start dividing by the numbers that I know are perfect squares, and 9 comes to mind, because 9 times 7 is 63. Now 7 is a prime number, but 9 is not, because 9 is 3 times 3. So again, here I have like a common, I guess I really like 3s. I've got these two 3s, and so for every 2 that's under this radical, it's equal to 1 on the outside, but I have this 7 that's left behind. So hopefully you're getting these right. Okay, so I do want to show you what happens. Okay, so I'm about to clear this, so if you need it, pause it. What happens if I have one that has a number in front? So this time I've got 4 square root 32. Alright, so 32 is divisible by 2. So I'm going to say 2 times 16. Now, look at that and say, can I bring that 2 down further? No, I can't. What about 16? Well, when I think of the number 16, I think, hey, that's a perfect square, because 4 times 4 is 16. So if I've got this 2 times this 4 times this 4, remember I'm looking for two of the same number. Now, I see a lot of students that just continue to break this down into 2 times 2 times 2 times 2. But that's a lot of extra work because I'm just looking for two of the same number. And if I have two 4s, those two 4s that are under the radical can come on the outside, and then I just have this 2 that's left behind. Now, I still have this 4 up top, and we can't forget about that. And if you'll just remember that numbers that are already existing on the outside multiply the numbers that you're pulling out of your radical when you're simplifying. So the final answer is going to be 16, because 4 times 4 is 16. 16 square root 2. So hopefully that makes sense. I'm going to do one more. If you need to look at this again, pause it. So I'm about to clear it right now. Okay, so this time I'm going to put a 3 in the front, and we'll do 12. So it's 3 square root 12. 12 is divisible by 2 times 6, or you could have done 3 times 4. Honestly, the 4 is probably the way I would have gone because that's a perfect square, but I'm doing it this way because I want to make sure you know that even if you don't use a perfect square, as you continue breaking these down into the prime factors, you will find hopefully find two numbers that work and that are the same under that radical. So 3 square root 12 is another way of saying 3 square root 2 times 2 times 3. And I've got these two 2's on the inside. And so for every 2 of the same number under that radical, it's equal to 1 on the outside. So it comes out, the 3 doesn't have a partner, he stays behind. And then you have this 3 right here that has to multiply against the 2 that you just took out. So when I multiply that, 3 times 2 is 6, square root 3. So that's the answer for that one. Okay, so the next thing we're going to do is talking about adding radicals. So when I'm adding radicals, it's the same principle as adding variables. So for instance, 2x plus 3x equals 5x. And the same thing is true when it comes to radicals. For you to be able to combine radicals, this radical right here has to be the same. So 2 square root 2 plus 3 square root 2 is going to equal 5 square root 2. Notice that the number under the radical does not add together. Think of it as having 2 cards that have the square root of 2 on it, and then adding 3 additional cards that have the square root of 2 on it. They don't magically become the square root of 4 cards. They're still square root 2. So we add the coefficients in front. The numbers in the front add together, but the number inside the radical does not. What if I have something like this? 3 square root 2 plus 5 square root 3. Okay, so let's think of it in terms of writing it as an equation with variables instead, where square root of 2 is represented by x, and the square root of 3 is represented by a y. Can you combine these two numbers? And the answer is no, because just like you can't combine an x with a y, you cannot combine two numbers that have different radicals. So they would both have to be square root of 2, or both of them have to be square root of 3 for you to be able to combine this and add it together. Interestingly, I saw a lot of people that understood this concept on the quiz, but when I gave them this, they added them together. And you can't add that one together either. In fact, if you need to see that as a radical, you could always rewrite this as 5 square root 1 plus 3 square root 2. And remember what I said, you can't combine the 1 and the 2 together because it's they're different numbers under the radical. So that's how you add radicals, and the same thing is true with subtracting. And in my next video, which is going to be short, I'm going to talk about multiplying and dividing these radicals.